Hey, welcome everyone to the third episode of Micropython series. Well, I'll make sure that you all get comfortable on using Micropython on ESP32 board for any of your project. So in this third episode, we'll be starting with interfacing BLE on our ESP32 board, of course by using Micropython for sending and receiving data between our smartphone and ESP32 board. And in the meantime, we'll be learning about hardware interrupts, hardware timers, and also some tricky things like classes and objects. So after watching this video, you'll be easily able to control the appliances via Bluetooth using the ESP32 board. Let's get started. If you're watching this video for the very first time, I'll suggest you to watch out the previous episodes of this series because each episode is a continuation of the previous episode. You can find the link of all the episodes in the description of this video. And that being said, let us start with episode 3. And first of all, you have to open the Thorny IDE on your computer. Now, before going into the Bluetooth part, let's just complete the interrupt and the timer part of the project. Let's start first with the timer part. For that, we'll first of all include the timer and the pin from the machine module by writing this command. Okay, after that, first of all, let's just configure the LED. Okay, for that I'll type a command as LED is equal to pin into the brackets the LED such at the digital pin 2, like the built-in LED. So I'll write 2 here, comma, I'll make it to be acting as an output device. Okay, so with this we have successfully configured the LED part. Now we need to configure the timer part. For that I'll create a variable called as timer, and I'll be assigning the timer, the hardware timer 0 to this particular variable. Okay, with this we have successfully defined the timer, and to initialize this we have to type this command. So let me explain you what this command includes. So first of all, we have to type the command timer.init to initialize the timer, and here we have some of the attributes to configure the timer. So first of all, the attribute is period. So we need to define after like how long this timer should last. Okay, so here we have defined 1000, that means it will last for 1 second. Okay, then we have to define the mode of the timer. Is it one time or is it periodic? So here I have defined periodic because I want to run this timer again and again. Okay, and here we have to define the callback, like after 1 second what we need to do, that we have to define inside the callback. Now here there is one new term defined which is called as Lambda. So Lambda is a kind of a special function inside Python which is used to write simple and single line commands or functions, you can say. Okay, so inside Lambda we just have to define what we need to perform. So basically we are defining a functions ultimately. Okay, so what we have defined, we have just defined that we want to write the value inside the LED as not of LED value. That means we are toggling this LED. So if the LED value is 1, it will be turned to 0, and if the LED value is 0, it will be turned to 1. Okay, so what we are doing using this function is we are initializing a timer of 1 second which will be called periodically, and after every second we are just toggling the built-in LED. So by this way we have successfully provided all the parameters to this timer, and we have initialized the timer as well. And that's it. By using these all commands you'll be able to use the timer inside your ESP32 board. Let's just try and upload this code onto the board and test it out. First of all, I'll connect my ESP32 board which is already connected. After that I will click on the stop button here. Okay, and after that I will click on the run button, click on Micropython device and save this file as main.py. Okay, I'll click on OK button, and yeah, it started running. Now if I open the smartphone's camera, then you'll be able to see that the LED on the ESP32 board is running, or we can say blinking, at the interval of 1 second. So after 1 second it is turning on, and after 1 second it is turning off. That is defined here inside the Lambda function. Okay, so yeah, this is how you can use the timer. Now let us jump on to the next part of the project or the video, we can say, which is to use the hardware interrupt. Okay, so for using the hardware interrupt, luckily we don't need to import any external library. Okay, so first let's just define a button here because that button will be acting as a hardware interrupt. Okay, so I'll define button, and it will be nothing but the pin 0, which is the boot button of our ESP32 board, and I will make it act as an input device because hey, come on, it is a button and it will be acting as an input device only. Okay, great. With this we have defined the button. Now let's just move ahead and define the interrupt part. Now to make this button act as an interrupt, you need to type this command. Now let me explain you this command. So here first of all we need to write button, which is defined here, and after that we have to write IRQ, which stands for interrupt request, and inside that we need to provide a couple of attributes. So first attribute is trigger. So here we have to define the trigger, whether it is a falling trigger, whether it is a rising trigger. Okay, so we have defined this trigger as a falling trigger. That means it will be activated as soon as the button is pressed. Okay, After that, we have to provide the handler, like what to do when a particular trigger is what we can say happened. Okay, so as soon as we press the button, what we need to do, that we have to define in the handler. So we are calling a function called as buttons underscore IARQ. Let's just define that function here as well. Okay, so I'll type the command def and I will paste this what we can say name here. So here is the function that we have defined. So as soon as the trigger happens, the Python will be redirecting you to this particular function. So here we have to define what we need to do. So we are just printing a simple line of code which says triggered. Okay, let's close it out, and that's it. Okay, so what these line of code will do, this will be blinking the LED at the interval of 1 second thanks to a timer, and it should also print triggered as soon as the button is pressed. So that's the code all about. Let's just try and test it out. I'll click on the play button, and yeah, hopefully it should work. So let's just turn on the camera before testing it out. So yeah, here is the ESP32 board, and here is the boot button. Okay, let's just try to press that button. But first of all, as you can see, the LED is blinking. That means the timer is working perfectly fine. Let's just press the boot button, and it says functions take 0 positional argument but 1 word given. So there is some error. Let's just try to rectify this error first of all. Okay, so the error was here. We have to just type pin here. Okay, so after writing this command, this was started working. Let's just test it out once again. I'll click on the play button. I'll turn on the smartphone's camera here. I'll take you to the screen, and as soon as I press the button, as you can see, it says triggered. Okay, and in the meantime, the LED is blinking. That means the timer is working. And as soon as I press the button, we are getting the triggered command. That means the interrupt is working. So this is how you can easily start, interface the interrupt or start using the interrupt and the timer on our ESP32 board using MicroPython. Okay, so that was about the small things that we have learned. Now let's jump on to the communication part, and let's try to interface the BLE on the ESP32 board. And for that, you have to use this code. Now don't worry, I'll be explaining you the code line by line, so you won't find any struggle to understand this code. Okay, starting with the importing the packages. So first of all, we imported the pin and the timer package. That's pretty simple. Now here from the time package, we have included sleep underscore ms. That means sleep in milliseconds. So earlier we used to import sleep, that stands for a number of seconds, or like delay number of seconds. While typing the sleep underscore ms, we can define the delay number of milliseconds. Okay, in terms of milliseconds. Okay, after that we have to import one more package called as ubluetooth, and luckily Python has built-in ubluetooth package, so we don't need to externally import it. Okay, so these three are the important packages, you can say. After that, here we have defined one variable called as message, which will be storing the data received via Bluetooth. So right now it is defined as a blank variable. Okay, after that, here is one new term defined as class. Okay, so here we have defined a class called as ESP32 underscore BLE, and inside the class, as you can see, there are so many different kind of functions defined. Okay, so now the question arises that what is class and how to use class, how to define class, how to define functions inside the class and everything. So earlier even I was not aware about the classes, methods and all these terms, and I got to learn about all this thing from an online course provided by DataCamp, which is also the sponsor of our video. So this course is called as Object-Oriented Programming in Python, in which we have these many chapters, and each chapter has some videos and exercises to be performed. Now the great part here is they have the built-in Python interpreter. That means after learning from the course, we can test our knowledge inside that same platform only without installing any external software. And we'll be also able to see if we are doing something wrong or not. Not only that, DataCamp has way more courses than this, which includes data science, SQL, machine learning, deep learning, and many more. DataCamp has courses for all different levels. Both newbies and pros can find great ways to grow their knowledge. So unlock the new career opportunities and become data fluent today. Use my link mentioned in the description box below to get the first chapter of any DataCamp course for free. Okay, so coming back to our video, so here we have defined the ESP32 underscore BLE class, which has different methods like connected, disconnected, IRQ, interrupt request, and which has their own attributes. Okay, so let's just imagine class as let's take an example of a customer class. So we have a customer class, and inside that customer class we have different methods like the name of the customer, the email ID of the customer, the address of the customer, and stuff like that. In the similar manner, inside the BLE class we can have the connected method method, we can have the disconnected, and basically all that events that are related to the BLE. Okay, so that's how easily you can understand about the classes and the methods in it. Okay, still I will let you know what are the methods meant for here one by one. So first of all, let's just skip this init first of all, which we'll be discussing at the last of this particular class. So first of all, we have the connected event, which will be occurred as soon as the BLE object declare is connected. Okay, so what we are doing as soon as it is connected, we are just turning the LED on and we are de-initializing the timer. Okay, while when it got disconnected, what we are doing is we are just initializing the timer at an interval of 100 millisecond. Okay, so basically after every 100 millisecond we are just toggling the LED, which reveals that it is now disconnected. It is searching for the new BLE devices. Okay, so this is all about connected and disconnected. Moving ahead with the BLE IRQ, that means the BLE interrupt request. Okay, so basically there are three types of event mentioned here: event 1, 2 and 3. Event 1 means the BLE device is connected. So as soon as the Bluetooth device is connected, the interrupt event 1 will be triggered. Similarly, if the BLE device is disconnected with the ESP32 board, the interrupt event 2 will trigger. And if we are receiving any message from the other BLE devices, the interrupt event 3 will be occurred. Okay, so connected and disconnected are pretty common. Let's just discuss the third event, which is receiving the data. So as soon as we receive the data, we are storing it inside the message variable. And if we have watched this particular code carefully, here we have made the message variable as a global variable. Now this global and local variable we have already discussed in the last episode, that is the episode 2 of our series. Okay, so you pretty much know about if you watch the series. Okay, so we are just storing that message inside the message variable and printing the message here. Okay, so that's all about the Bluetooth interrupt request method. After that, here one more function or method is defined called as register, which contains all the UUIDs of our Bluetooth device. So we need to keep it as it is. You don't need to change anything. Okay, straight after that, here we have two more method. One is send and one is advertiser. Advertiser means whenever this device is disconnected, we are advertising our own data, or we can say own name to the nearby BLE device. That's what the task this advertiser does. And if we want to send the data from this BLE device to another BLE devices, maybe a smartphone, we'll be calling the .send function. Okay, and we'll be sending the data. It takes the data as an input, as an attribute. Okay, so now the last thing which is remaining is this init, or method. So what is this init? So this is a special method inside the Python, which has some special characters to be defined. So it is defined in this manner only, like underscore init underscore. Now why this is special? Now this is special just because whenever we are calling any method from this class, maybe it's connected, disconnected, any method, this method will be called first, and after that the other methods will be called. Okay, so the common variables or the common task or the common functions are defined inside this particular init method only, because this will be called every time. Okay, so with the help of this, we no longer need to define each and everything separately inside the separate methods. Okay, that's the benefit of using this method, which is also called as constructed. Okay, now here one more thing is remaining, which is this self. So as you can see, everywhere the self is defined. So what it is, okay, so first of all, this self doesn't really help in getting any attribute. For example, if we took the send method, so we just need to type the data inside it. Okay, so we are sending just one attribute, but here we have defined two different attributes. So like what the self is all about. So self is kind of a compulsory term which need to be entered in every method. Okay, so this is like a compulsory thing you have to do. Okay, so that is all about the classes, methods and the attributes inside this particular MicroPython. I hope you got to know some basics of it, and if you want to understand in detail, you can definitely check out those courses. Okay, straight after that, let's just jump directly into the main part of the code. So here we have defined the LED as an output, button as an input, and we are initializing, or rather we have declared a BLE object. So we are basically starting our Bluetooth device with the name ESP32 BLE. Just change it to just ESP32 only. Okay, so our ESP32 device will be advertised with the name ESP32. Okay, straight after that, here we have defined the button interrupt request. Okay, so here we have defined the button interrupt. Now this is the same interrupt that we have discussed in the previous code. So here what we are doing is we are just defining the interrupt with the falling. Okay, it will be a falling trigger interrupt, and as soon as this interrupt occurs, we are just calling the function called as button IRQ, which is this function. Okay, so as soon as this function is called, what we are doing, we are just toggling the status of LED. After that, we are sending the data as LED state will be toggled to the Bluetooth device, as you can say BLE.send, and we are also printing the same thing inside our Python terminal. Okay, so that's about the interrupt. Okay, and after that, inside the main while loop, what we are doing, we are first of all checking the message. If the message received is status, if is it so, first of all clear that message variable. Okay, and after that, these two lines will just return whether the LED is on or off. So this is kind of written in a very different way. Let me make it very simple for you. So basically these two line means the same thing that is defined here, but it is written in a much compact manner. Okay, but this is much more easy to understand. Okay, so basically if we send the word status from our mobile phone to the ESP32 device, it will just return whether the LED is on or whether the LED is off based on the LED status. Okay, so yeah, that's a simple line of code just to send the data via Bluetooth and also to receive the data via Bluetooth. Now let's just try to upload this code onto the ESP32 board and let's test this thing in action. Okay, so I'll click on the stop button first of all, and after that I'll click on the play button. Okay, the code started running. I'll turn on the smartphone's camera just to let you know everything. As you can see, the LED on the phone started blinking rapidly. That means at the interval of 100 milliseconds, that reveals that this device is not yet paired or not yet connected. Okay, I'll take another smartphone here, and here inside the smartphone, I'll open the application called as Bluetooth Terminal, which you can easily find it on the Play Store. After that, I'll click on this icon and go to devices. Okay, now here I'll connect to the ESP32 device. As you can see, the LED stopped blinking. That means it is now successfully connected. It also shows a connected status here inside the smartphone. Okay, so now if I type the word status here in the capital letters, and if I send this to the device, as you can see, it says LED is off, and LED is actually off on the ESP32 device, and the same data is printed here as well, which is LED is off. Okay, now I will test the trigger interrupt. So I'll press the boot button and I'll turn on the LED. As you can see, the LED turned on, and I got the data here that LED state is toggle or will be toggled, and same data appeared here, LED state will be toggled. And if I ask for the status now, I should get LED is on. Let's just test it out. Okay, it says LED is on, and that same data is reflected here, which is LED is on. So yeah, we are successfully able to send and receive data via Bluetooth. The timer is working fine, the interrupt is working fine, and the BLE communication things is also working fine. And that was the agenda of this particular video. And by this particular thing, you can also make the smart home project which we already made. Look at this particular video. So in this video, as you can see, I'm able to control the bulb using my smartphone application, and this is happening via Bluetooth. And I have written the code for that, which I'll provide it inside the description of this video. So do check out the description to get the code for this particular project. So yeah, that was all about the third episode. I hope you find it interesting. I hope you got to learn something new from it. If it so, do click the like button. Also let me know in the comments, like, what do you want to learn next inside this MicroPython series? Do let me know in the comment of the video. Also share this video with your friends who you think should start learning about MicroPython from very basics. And that being said, I'm just ending this video here and now. Just wait for my next explore, learn, share with me, techiesms. Bye.